What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today we are doing one final prediction video. Sorry for the last minute stream. I didn't post this ahead of time. I'm on the road right now, but I want to make sure to get out some predictions for you guys tomorrow. So I released practice test 7 late last night, I believe, or the night before. That was a walkthrough that I've been wanting to do for a while. So make sure to check that out. That is of one of the newly released digital SATs. And I went through that entire math section, module 1 and module 2. And this is the video where I did that. So I'm sharing this right here. And this is going to give context for my predictions. And I'm basing it largely on what I've seen prior to this, but also largely on this practice test and some of the trends that I'm noticing here. So what I'm going to do is I'm going to step through some of these problems. Now, look, the predictions are going to focus on more of the nuanced questions. Obviously, there's going to be more questions than simply what I'm predicting or what I'm showing here that are going to be on the test. A lot of your standard linear equations, systems of linear equations, all your good quadratic stuff, all that's still going to be there, of course. But I want to hyper focus on the nuanced questions, the questions that are a little bit different or modified, and that might be especially tricky. So that's what I'm going to talk about. Now, we're going to start off right off the bat with, you may say this one doesn't look that tricky in particular, but I guarantee you they're going to have some sort of triangle problem where you have to draw it out. And I think this goes back to the main theme that what the College Board is doing for the digital SAT is they're moving in this trend where they're trying to do more problems where you actually have to make drawings or you have to think critically without just simply using Desmos as a major crutch. And so these problems, I think, will definitely be in play, whether it's drawing out triangles saying what's sufficient or what's necessary to prove congruent or similar, or in this case, just drawing out two triangles that they're telling you they're similar. And then you have to figure out the measure of an angle or a side based on that relationship. So this is one in particular. I'm going to just be skipping through the problems until we get to the next one where I'm like, yep, this is okay. So the next one that I'm stopping on here, I also think is something to expect. This is a ratio equivalence one, but now you're going to see on the left-hand side when I actually go to solve it, I create a ratio, I create a proportion, and using that, I can then solve and isolate. Now, one of the interesting things to note here is they're asking about, hey, what is, this one is just setting it up. What is the value of y? But other ones, they might be like, what is the value of x over y or y over x or whatever it may be. But the point is the same in any of these questions, is to set up a good equation. And this is a general theme throughout. Set up a good equation, a good proportion right off the cuff, and then cross multiply and manipulate as need be. Okay, we're going to keep it going. Moving on to the next one. One second. All right, so then we have this. Okay, this is not a bad one either. I feel like something like this is going to pop up as well, where you're trying to find values associated with particular variables. In this case, it's going to be the points assigned to these particular tokens, I guess. And again, this is something where when you're asked a question like this, you want to look at those coefficients, and those are usually going to give you the point relationship of or the value of these particular items. So again, here it's going to be 80 for the square tokens and 90 points for the the circle tokens. It's again because of those coefficients. So that's something very important to take a look at. Okay, we're going to move on to another noteworthy question. I'm going to keep skipping through. All right, that's a pretty standard isolating quantities question right here. Pretty standard circle question. Not going to flag that one. Okay. This was interesting. This asked about slope, but using the term average rate of change. And just as something to point out, especially when you get into higher levels of math like calculus and stuff, we're talking about average rate of change. A little bit more frequently, perhaps, in terms of taking 2 points or 2 points on a function and just calculating that secant line, that slope line. But that's the bottom line here is when they say average rate of change, just immediately think slope and then get that coordinate at 5, get that coordinate at 7. And that's what I did here. You can see it with my work on the left-hand side. And I'm saying subtract down to calculate the slope, difference of the y's over the difference of the x's. And that's how you do it. Okay, so that's another great one. This is classic system of equations. Not going to focus on this. Moving along here. That's a pretty standard exponential. Yeah, this one is worth talking about. This one is also good too because this is a solving an equation. Now, your instinct might be like, hey, I'm going to solve for x and then I'll plug it into the expression at the end. And you could do that. It's not going to be wrong, but it's very nice if you look at that 2 minus 4x, that expression is a singular variable. That's what I did here. So I set it equal to y, and then I did some substitution. I'm like, oh, now I just solve for y because we're trying to solve for that expression. I'm setting y equal to that expression. There's no solving for x and plugging back in. So that's a nice little handy trick there. And I do think something like that will come up for sure on this test tomorrow. This one was pretty much a typical percent problem. Nothing crazy here. Again, just set up an equation, knock that one out. This one is a great one. Okay, this is a quadratic, but they're hinting at you that you have to solve it with the quadratic formula. Again, meaning you can't really do it on Desmos. I mean, you kind of can, but this is going to be much better solved by hand using the quadratic formula. And then it's also important to note that this one was a little tiny curveball because you can't simplify this. So you might look at the answer here that I got, right? 8 minus rad 120 over 4 and be like, I can simplify radical 120. I can extract the 4 out and make it 2 rad 30 and then simplify. But you have to look at how they presented their answer in the answer choice, 8 minus rad k over 4. So you want to leave it like, look, I pretty much have it exactly like that. I got the 8 there, I got the 4 there. So then that tells me I don't want to simplify 120, and 120 is the answer for k. They've had other versions of this where you will get the wrong value, get the wrong k value if you didn't extract, if you didn't simplify that radical. So that's very important. Okay. Let's keep going through this. Come on. Give me to 21 here. 1 second, guys. There we go. Oh, this one was really good. Okay. So this was a little new too. All right. This is in my formulas video, right? One of my most watched videos. I say it's important to know that cosine of an angle is equal to sine of the complement of that angle. And usually that's what the College Board does with those types of questions. They changed it here. They gave a variant. So in this one, it does still come down to the fact that cosine of an angle is equal to sine of an angle, but you had to think like, all right, first of all, so what could I do here? I could change sine of 24 into cosine of 66. And then what would that be? It wouldn't be 2 cosine 66. It's cosine 66 squared. So you're converting to an equivalent trigonometric expression, but with these hard values, like you don't have x or y, you don't have variables, which I also thought was a little funny. And then you could have you could go multiple ways with this. Like I could make this sine 66 squared, or I could make this cosine 24 squared. Likewise over here, I can make this cosine 66 squared or sine 24 squared, because it could go either way with the equivalency. So this was a very interesting one. And again, because it's different, I think you're going to see something along these lines on the March test. Again, there's going to be all these variations. There's going to be some people that are going to come back and say, yes, I saw exactly this. Others that are saying, yes, I saw exactly that, because it depends on which version you get. Okay, that is all the stuff from mod 1. Now we're going to go through mod 2 here. Let's check this out. Okay. And nothing too fancy here. That's just reading a graph. Line of best fit. Slope, nothing crazy here. This one is, yeah, this is just a percent problem, typical percent problem. Again, if you want to see how I did it, watch my video and you can see how I actually solve it if you have any questions. This one wasn't anything special either. You're just trying to match the function to the table, and you could plug in these values and figure out which one it is. Straight up, nothing crazy. This is your typical margin of error. Nothing crazy there. Yeah, really nothing crazy either here. It's a similar one where you're trying to solve for an expression, but then you want to get x in particular. So that's a typical linear equation. Wait. Oh, yeah, this one was a little interesting. This one was a little different. Okay, I'm going to flag this one. So this is a hybrid function notation and then equivalent expression problem. So you're trying to solve for this value of b. And you see that b exists in f of x. And what they're asking you to do is they're saying, hey, if you multiply f of x and g of x together, it equals this expression, 9x or whatever function, 9x to the fourth minus 26x cubed minus 3x squared. So what you have to do is first you have to understand that function notation means you're taking the product of those functions. So we multiply the functions out. Then we try and match it with what they gave us, right? So we're trying to do that after the fact. And then you have to look for equivalent pieces, set them equal to each other, and that's how you can solve for b. But because of the combination of steps, function notation understanding. Okay, check. Now we have to multiply these two together. That's foiling. Check. Then we have to match it and just use logic. So because of that, it's a little nuanced, a little different. I would review this question as well, but I could see them putting something like this exactly on the SAT. Or maybe they do two functions dividing each other's. Again, something involving that function notation, interpreting that, and then getting that equivalent expression. Okay. Here we go. In the line, this point passes through the... Now this is a typical parallel equation problem. Let's see this one. And again, for those of you guys who are joining now, I'm showing the questions that stood out to me as unique or different. And I want you to use these are how I'm figuring out what I think is going to be notable to predict for tomorrow's test. And again, the standard stuff I'm not focusing on because you probably had loads of practice on different practice tests or whatnot with those types of problems. But what you want to watch out for are these little permutations, these little deviations, and make sure to hit these newer question types that you may have less experience with. Okay, so this is a pretty standard one. We're just trying to find the minimum. Okay, I always want to point out these ones. I know these are going to show up because they require you to draw out a triangle. You can't really use Desmos, and I know the College Board is going in this direction. So I do want to highlight this one. You got to make the diagram very carefully, which I did there. And then once you get the diagram, then you just fill everything in. Fill in the angle measures like I'm doing here. Fill in the side measurements to whatever extent they give them to you. I don't think they gave anything here. But then with the angles, then it's a puzzle. Then you're like, okay, now I know this angle. I know that has to be a right angle. I know this angle then has to be 27 because it's complementary with 63. So you fit the pieces together, and then you can find whatever angle you need to find. In this case, it was XPQ. This is just an inequality, and you're figuring out the inequality, how to write it out, match it up with the correct one. But we've seen these before, so won't focus a ton on number 13. Okay, let's get into 14. I think these are some of the tough ones because, yeah, oh my God, this one was so hard. So this is I think, is this the one I got wrong? Hold on. I think this is the one I got wrong. So I got one question wrong when I took this, and it's not like we haven't seen anything like this totally. Like it's a system of equations that has infinitely many solutions. We know that means they have to be equivalent. What made this so hard was you're not just solving for G, you're not just solving for K, you're solving for the ratio of the two. And to get to do that, it takes at least the way that I did it. You have to realize that we got to get them looking equivalent. And then I matched up the X coefficient. Like I got to get the constant at the end equivalent. So 2/7 and 5/2, I made those the same. And you can see my work on the left-hand side as I'm kind of talking about the problem. So you make those the same. And then once you make those the same, you match up. You see how I see right there how I got them to be both 5/7. I multiplied, the 5/2 by 2/7, the 2/7 by 5/2. And then I just match it up. I'm like, okay, now the coefficient 1 has to equal 2/7 G. And then for K, it's a similar equation. It's 2/7 K equals 7/2. Again, matching the coefficient. But I made a little mistake here. And I got 7. I said 7/2 times 7/2 was 49/2 instead of 49/4. Make one mistake. And when you got all these moving pieces, and then and the end is a free response. Another complication. I ended up getting this one wrong. So this is another really good one that I want you guys to pay attention to in terms of just getting all those meticulous steps down and understanding what are they saying. We also have to know, what does it mean if it's no solution with a linear equation? Parallel. What does it mean if it's infinite solutions? Same line like that. Okay. This is also one that stands out. I got to go in 2 minutes because I have to jump on a tutoring session. But this is another huge one where you have to create an equation with the constant in the mix. And not only that, your go-to might be slope-intercept. That's what I did. And then you have to convert it to standard form. Okay. I want to make sure to get, there's one question in particular that's really important that I want to show you guys here. 1 second. I think it was later in the game. Not this one. This one's pretty standard. Was it this one? This was a cone. This was interesting because they talked about slant height. So slant height is my calculator's blocking this, but slant height is now in the mix. They didn't really used to talk about that, but with a cone, they're talking about this blue section right here. So that's another thing I want to point out to you guys. They might throw out this term and you might be less familiar with it because it didn't used to show up as much before. Slant height. Remember that. Okay, let's keep it going. A couple more things I want to show you. This question, they have a problem like this before on one of the older tests. So I did this in one of my hardest SAT problem videos. Watch this in particular because, and they did the exact same thing on this practice test. You recognize that the two equations are equal and then you have to get general solutions. And just watch how I did it because watching how I do it will give you a lot of insights on how to tackle it on your own when you actually come across this. But it's a very hard, I think it's a really hard problem that you should definitely practice. Okay, 21 and standard problem. We've seen a bunch of those already. This is the one I had to get to you guys. Miles per minute squared. They've never done this before. So we've done feet squared, inches squared, these types of things. So that I think could throw a lot of people off. And I think some people might be less likely to catch that. Hey, it's just 1 minute is 60 seconds squared. They may miss that, but it's that same relationship. Miles per minute squared. There's a different relationship. You see how I squared it when I converted it. So I said if we're talking about squared seconds and squared minutes, it's the same thing. We have to have 60 squared seconds to 1 squared minute. Okay, that's it, guys. I hope that helps. I hope that makes sense. But again, these predictions have been grounded from the fact of these newer tests and these new question types that I've noticed. Really quickly, Anne says, all the way from Africa. What's up from Africa? Thank you so much for joining. Best of luck to you. And then we've also got, I'm so worried. I'm so bad at math and have a problem memorizing formulas. I'm good with Desmos. Utilize Desmos. That's going to be a huge crutch and a huge key to helping you be successful. But do your best with the formulas as well for my formulas video to the best of your ability. You did what you could. Do the best you can with confidence. Let's go. Okay, guys, I got to bounce. I wish you all the best of luck tomorrow. Thank you so much for joining, and I'll see you in the next video. Take it easy.